Very good afternoon to all of you and welcome to the physics class live. So we are just going to start the topic we were discussing in the previous class. That was the projectile motion we were discussing. Okay. So we'll be seeing velocity at means say any instant. Okay. So far we have discussed about the path of projectile is parabolic in nature. We have derived equation for that. Okay, and we have also seen the time of flight and maximum height and the range. Okay, so range we were discussing. Okay, so we'll start from range only. So we'll see how we can calculate the range of projectile. Then we'll see how we can just calculate the velocity at any instant, and after we'll discuss about the some other cases like projectile from certain height, and we'll discuss those things. Okay, so coming to the basically the topic, that is the range of the projectile. Range of projectile. So I was discussing these things, I think, in last class. Range of projectile. So this I was discussing. Let's say this was the case of projectile. The ball is thrown like this, and this was your initial velocity. Let's say this was your theta angle, and this was u. So this was your, you can say, this was your x-axis and this was your y-axis, and we have discussed the time of flight for this motion. So this was t is equal to u sine theta by g. This was the case. This is the time of flight. Okay, so we are willing to calculate the range of projectile. So range is horizontal distance horizontal distance traveled during projectile motion. So how much horizontal distance will be here? So this is basically the horizontal distance during the projectile motion. So how we can calculate this one? So taking motion along x-axis, motion along x-axis. So if you're talking about the x-axis, so we can write here the range is equal to velocity along x-axis into time, means u cos theta, means along the x-axis, here will be the velocity, this will be your u cos theta, and along this will be your u sin theta. Okay, so range u cos theta into time of flight. So we can put the value here, u cos theta, and the time of flight is your 2u sin theta by g. Now you can just multiply these, and this will become u square 2 sin theta into cos theta by g. So this is the formula. You should remember the half angle formula. Sin 2 theta is equal to twice of sin theta into cos theta. So in place of the 2 sin theta cos theta, we can write here the range can be written as, this can be written as u square sin 2 theta upon g. So this will be the range of the projectile. So if you are asked to find out the maximum range, okay, so maximum range means what? You know, the maximum value of sin theta is 1. So the maximum range will be obtained at theta is equal to 45 degree. How we can calculate that? Let's see here how we can just calculate. So this is the case. R is equal to u square sine 2 theta by g. This is your range of the projectile. Okay, and for max of range means range max. So you can write here the sine 2 theta should equal to 1, and it will be only 1 when theta is equal to, means this much should be 90 degree, means sine 90. So when you will solve it, 2 theta is equal to 90 degree and theta is equal to 45 degree. If theta will be 45 degree, there will be the maximum range. It means what? If you are throwing any object, if you are throwing any object with angle 45 degree, then it will travel maximum distance. So this can be used while playing cricket. जब हम लोग क्रिकेट खेलते हैं तो ये यूज करते हैं कि अगर मैक्सिमम हॉरिजॉन्टल डिस्टेंस कवर कराना है किसी ऑब्जेक्ट को, सो वी कैन थ्रो द बॉल विथ एन एंगल 45 डिग्री. अगर 45 डिग्री से हॉरिजॉन्टल से इसको थ्रो करेंगे तो ये मैक्सिमम हॉरिजॉन्टल डिस्टेंस ट्रेवल करेगा. सो दिस इज द बेसिकली रेंज ऑफ द प्रोजेक्टाइल. इज इट क्लियर? I hope it is clear to all of you. Okay, coming to the next, velocity at any instant. We are just going to find out the velocity at any instant. Velocity at any instant. Let's see it, how we can find. We have discussed so far that if any object is thrown like this, thrown with angle, you can say theta, okay, and this was the time t is equal to 0, and let's say this is x and this is y. So we are willing to find out velocity at t is equal to t, means at any time we are willing to find out the velocity of this object. So at this instant you can see this will be the component of the velocity and this will be the vertical component. This was your horizontal component, that is, let's say Vx, and this will be the vertical component Vy, and this will be the final velocity at this instant. So I already told you that the horizontal component of velocity remains constant throughout the projectile motion. So if it is u and the horizontal component will be along u, so this will be your u cos theta, that is going to be constant throughout the motion, throughout the projectile motion. So this is u cos theta and this will be your u sin theta. So what we are going to do, we are just going to take motion along, once will take along x-axis and once will another time will take along the y-axis, and we'll see the vx and vy, and these are the vector quantity and these are acting at angle 90 degree. So we'll just calculate the resultant of the velocity. So taking motion along x-axis, taking motion along x-axis. So you can see that along x-axis, the u cos theta will be constant. U cos theta means component of velocity will be constant. This is constant. So at time t, the velocity along y-axis, the velocity along x-axis is going to be u cos theta. If you are talking about me taking motion along y-axis, taking motion along y-axis, so using first equation of motion, so कोई हमसे ये पूछ सकता है कि why we are using first equation of motion in case of the y, why we are not using any equation of motion along x-axis? So the answer is, along the x-axis, the velocity or speed of projectile motion is constant. There is no acceleration along the x-axis. So acceleration is along only the y-axis. If there is a constant acceleration, then only we can use the equation of motion. So that's why we are using the equation of motion along y-axis only. Along x-axis, we are using simple formula: speed is equal to distance upon time. So using first equation of motion, we can write here Vy is equal to Uy minus Gt. So we can write the value. We are willing to calculate Vy. So, and Uy is initial velocity along x-axis is u sine theta. This is Uy. And this is your Ux. So this will be your u sine theta minus Gt. So you can see here, this is velocity along x-axis. This is first equation. This is second equation. Now you can see these are at 90°. In vector form, you can write like this: V vector is equal to Vx I cap, Vy j cap, or simply you can write this is the case: U cos theta I cap plus U sin theta minus Gt j cap. Or simply, if you are willing to calculate the magnitude, so magnitude will be square and summation of the coefficients of I and j, and you can see the here these are at 90°. So magnitude of velocity will be your, this will be your u square cos square theta plus u sin theta minus gt whole square. And if we are just means expanding these terms, so we can write here magnitude of velocity at any time t. So this will be your u square cos square theta, u square cos square theta plus this will be your u square sin square theta plus g square t square plus minus 2u sin theta gt, sin theta g into t. Okay, so if this is the case, we can just take u square common here and we'll get here the magnitude of velocity. So this will be your u square plus g square t square minus 2u sin theta into gt. So this is the case how we can just calculate the velocity at any instant. Okay, is it clear to all of you? Let me know. Yes. Okay, so means people are just sleeping. Okay.
Yes, sir. Yes.
Yes, sir.
No, sir, we are awake.
Okay, if you are means just not sleeping, then let me know by saying yes or no you are getting or not. Okay. So coming to the another aspect of this projectile motion.
Yes, sir.
Okay. So let's understand what will happen if we throw any object from certain height. Okay. Then at that time, what we can discuss means what we can find, how we can find. So this is the case for projectile from certain height. Projectile from certain height. Suppose this is basically the tower H and a ball is thrown. So ball is thrown by velocity u. So once this ball will be thrown, this will falling downward like this. This will be coming downward. Initially it have given velocity u. Okay. So but it will come to downward due to the acceleration due to gravity, because the g acting is vertically downward at every point. So due to g only, this will come to the downward. So we can write here, let's say an object is an object is thrown along x-axis from tower of height h, okay, with velocity, with initial velocity u. So you should understand, if you have given u velocity, अगर आपने इसको u दे दिया है, याद रखिएगा, जब आपने अगर इसको u दे दिया है तो u विल बी कांस्टेंट, ये u चेंज होने वाला नहीं है, क्योंकि देयर इज नो एक्सेलरेशन अलोंग द एक्स एक्सिस, एक्स एक्सिस के अलोंग कोई एक्सेलरेशन नहीं हो रहा है, तो आपका ये u जो है वो चेंज होने वाला नहीं है। तो अगर u चेंज नहीं होगा तो ये इसकी वजह से ड्रैग हो जाएगी। सो अब ड्रैग हो जाएगी तो ये कितना टाइम लेगी यहाँ पे पहुंचने के लिए और कितने डिस्टेंस तक ये ड्रैग होगी, मीन्स हॉरिजॉन्टल डिस्टेंस हो गया, ये बेसिकली इसी को हम क्या कह देते हैं, रेंज कह देते हैं। तो यू कैन सी टेकिंग मोशन along y axis, motion along y axis, so you can see here, अगर हम y axis की बात करते हैं तो there is no any component of velocity along y axis, y axis के along कोई भी initial velocity का component नहीं है। तो अगर initial velocity का component नहीं है तो ये नीचे क्यों गिर रही है, it's falling downward only due to the acceleration due to gravity, केवल acceleration due to gravity के कारण ये ऑब्जेक्ट नीचे गिर रहा है। तो यूजिंग second equation of motion, second equation of motion, what is the second equation of motion, we can see this is the case, ut plus half gt square. So we are talking about the motion along y axis. So you know the vertical component of initial velocity is 0. Here only the horizontal component it have, that is u, and the vertical component of initial velocity is 0. So we can put here the 0, ui will be 0, so h will be your half gt square, and this we can calculate the time from here, this will be under root 2h upon g. This will be the time, this will be your time to reach at the ground, time to reach at ground, time to reach at ground. So in the same time it will be dragged along the x-axis, that is the basically range. So how we can just calculate the range? So range can be calculated, range of projectile is velocity along x-axis, that is your ux, into the time taken by the projectile motion. So this will be your u, and the time is your under root 2h upon g. So this will be the range of the projectile for this case. And once it will reach to here, look here, once it will be reached to here, it will be hitting the ground. So sometimes they ask what will be the hitting velocity, what will be the velocity by which the object will be hitting to the ground. You can see from here, this is the horizontal component that is going to be constant, and now whenever it will reach here, it will acquire certain velocity. This is the, it will acquire certain velocity. Let's see, and we'll find out the resultant of these two. So Vy we can calculate using equation of motion along y axis, though this will be your initial velocity along y axis is 0. So this will be your gt, and initial velocity along x axis is your u. Okay, so you can just add these two at 90 degrees. So I am just using the another color pen so that you can understand here. Vy is nothing, it's a gt, because uy plus gt, initial velocity along y-axis is just 0, so this will be gt, and velocity along x-axis is u only, and these are at 90 degree. So velocity at this instant, v means hitting velocity, will be your vy square plus vx square, or you can write here gt whole square plus u square. This can be your velocity by which it is hitting to the ground. Okay, so these were the cases. These were the cases of the projectile motion. So let's discuss some question based on this projectile motion. Okay, so how we can just calculate, means how we can just go through the questions. Okay, coming to the next page. So question is, find relation between height and range in projectile motion. In projectile motion, they are asking, we have to find out the relation between height and range in projectile motion. So we already know about this. Suppose this is a projectile motion. This is the case of projectile motion. This is angle theta, and this is your u, and so this will be your u cos theta, and this is your u sin theta. We have already discussed, once the particle will reach here, the vertical component of velocity is 0, and the horizontal component of velocity will remain u cos theta. So at this point, this height will be your u square sin square theta upon 2g, and the range of the projectile we have discussed right now. So this will be your u square sine 2 theta upon g. So this is our first equation, and this is our second equation. They are asking the relation. How we can find out the relation? We'll just divide these. So by first divided by second. So this will be your h by r, and it is your u square sine square theta upon 2g divided by u square sine 2 theta upon g. Now we can just cancel out these u square, and these g will be cancelled out, and this can be further written as h by capital R is equal to, this will be your sine square theta, and this is your 2, so it will be multiplied here, and this will become your 2, and sine 2 theta, once it will be expanded, this will be 2 sine theta into cos theta. So sine theta and this square will be cancelled out, this will become tan theta. So this will be your h by, and this r is equal to tan theta by 4. So this tan theta will be your 4h upon r. So this is the basically relation between the tan theta and the range. Okay, this is the basically relation between the tan theta and range. Okay, one more important point, one more important question, or you can say the important points. If you are talking about the projectile, okay, and if you are talking about the coordinate axis, so when it is here, means when particle is here, you can see the x-axis is your range, and the y-axis is your 0. So the coordinate of this point will be r comma 0, because the y is 0. Okay, and at the highest point, you should remember this, at the highest point, this is at a maximum height, So x will be at r by 2 distance, means the coordinate of this point will be r by 2 comma h. The coordinate of this point is r comma 0, and the coordinate of this point means coordinate at highest point will be r by 2, that will be half of the range, comma h. H is the max height, and the relation between these are the tan theta is equal to 4h upon r. Okay. So coming to the another aspect, another question, that at any instant they can ask for the angle of projection. So there is one question that is given in the NCERT. So that question I am putting, and we are just going to solve that question. Find, question is, I'm not writing exact question, but I'm just writing the sense of question. Find angle of projection at any instant t during in projectile motion. Okay, how we can just find out the angle of projection for this? So we'll assume here let's say an object is thrown with initial velocity u, making an angle theta from horizontal. As shown in figure. So once we'll draw the figure here, the object is thrown like this. Okay, and this is your basically u at t is equal to 0. This was the thing. This theta will be there at any time t. Let's say this at any time t, this particle is at here, and here will be the vx, velocity along x-axis, and here will be the velocity along y-axis. Now we can see this will be the resultant v, and this will be the theta, that is once again the angle of projection. This theta is your angle of projection. So we know if it is thrown with u, the horizontal component of velocity is going to be your u cos theta, and vertical component of velocity is going to be u sin theta. These are the initial component. At time t, the velocity along x-axis, the final velocity along x-axis will be your u cos theta only, because this is going to be constant. Okay, but the velocity along y-axis will be changing. It will keep decreasing, and once it will reach to the max height, its velocity will become 0, and after achieving the maximum height, its velocity will once again start increasing. First it will decrease, then it will start increasing. So this is the velocity along x-axis. This is velocity along x-axis. So now velocity along y-axis, using first equation of motion, Vy will be your u sin theta minus dt. You can see here in this triangle, let's say this is O dash, and this is your A, and this is your B. In triangle OAB, B. So you can write here the tan theta. What will be your tan theta? Tan theta is your perpendicular. This is your AB, and this will be perpendicular by, this will be the base. Base is your O dash A. And you can see here this tan theta, AB. So this is basically Vy, and the Vy we have written. This is your U sine theta minus gt, and O dash A. Along this, there will be the horizontal velocity. This is your U cos theta. So you have to just discriminate here. You have to just discriminate here this theta dash. So this theta dash will be your tan inverse. Tan inverse this Vy and Vx. This is your U sine theta minus gt, and this is your U cos theta. Okay, this is the case. U cos theta will be there. So you can see they have asked find angle of projection at any instant t. So initially the ball was projected from theta angle, and here the projection is your theta dash. So you can just calculate this angle. Okay, you can just calculate these things. Okay, and this will be your theta dash, and theta dash will be your tan inverse U sine theta minus gt upon U cos theta. Okay, so in the similar way we can have another questions also. Suppose sometimes it is asked like this. This question can be asked like this. Suppose there is a roof. Okay, there is any roof, and the distance of roof they have given, already given. This is, let's say, h meter. Okay, so they are saying that if any person is throwing ball, then throwing with angle 30 degree or something like this. Okay, then what should be the velocity of that ball so that it can just come back to the ground without touching the roof? It can just come back to the ground without touching the roof. छत को छुए बिना कितनी मींस कितनी वेलोसिटी हमें फेंकें ये छत को छुए बिना ये वापस आ जाए. तो उस कंडीशन में भी हम यही यूज करते हैं. आपका क्या मैक्सिमम हाइट का फॉर्मूला एच वी नो यू स्क्वायर साइन स्क्वायर थीटा अपॉन 2g. So यहाँ पे you are provided h, you are provided theta, g is known and you can find out the u. तो ये एक अलग तरह का क्वेश्चन बन सकता है. इस तरह से हम लोग कर सकते हैं. ओके, अनदर पार्ट हम लोग कैसे कर सकते हैं ये भी जरा समझा जाए. हम लोग दूसरे तरीके से दूसरा क्वेश्चन अगर मान लीजिए कभी इस तरह से आ गया. सपोज यू हैव गिवन एन इक्वेशन ax माइनस bx स्क्वायर. तो यहाँ पे अगर कभी पूछ लिया जाए कि आप रेंज बताइए, टाइम ऑफ फ्लाइट बताइए, तो whenever you have given this equation, you should just compare this equation with this means equation of the parabola, that is y is equal to x tan theta minus half gx square upon u square cos square theta. So what you can do, you can just compare this equation to this equation, and you can have whatever value you are willing. You can find out the value of range, you can find out the value of maximum height, you can find out the value of angle of projection. Okay, so for this I can take one example. Suppose this is equation of the projectile they have given so far. You know, at the if you are willing to find out the range, maximum horizontal distance, you know, maximum horizontal distance is that distance when basically y is 0. This is the coordinate. We have already discussed the coordinate of this. This will be your r comma 0. Okay, x-axis comma x comma 0. So we can put the value of value y here. So y 0 ax minus bx square, and we can find out the value of x. It will be 0 or it will be a by b. So at 2 points, means when x is equal to 0, and you can see, so y will be 0 when x is equal to 0, and x is going to be non-zero when y is going to be 0. So this will be a by b will be your range. So in this way we can just calculate the things they have asked. Okay, so here we have just completed this projectile motion. So in the next class, we will be starting the next chapter, that is your laws of motion. Okay, that's it for today. Thank you.
Thank you, sir.
Thank you.